Hello, dear students. So today we are going to discuss another topic in fundamental of operating system, and that is multiple process scheduling. So multi process basically the name of multiple, right? So multiple means that more than one process, right? So multiple processor scheduling or multi-processor scheduling focus on designing the scheduling functions for the system which is consist of more than one process. Okay, so a very important point over there. First of all, that if we are considering more than one processor, okay, so more than one consists of more than one processor represent the multiple processor scheduling, right? So with multiple processors in the system, the load sharing becomes feasible, but it makes scheduling more complex, right? So if we go with multiple processes, then we find out that the feasible the activity is over there. Okay, but at the same time, while we are working with multiple processes, then it can also make a system complex, as there is no policy or rule which can be declared as a best scheduling solution to the system with a single processor, right? So there is such certain kind of policies or rules are not over there for that the best solution of the system is all about the single processor. Similarly, there are no best scheduling algo solution for a system with multiple processor as well as in this section, we are going to discuss about certain kind of things that which is very relevant with multiple processor and all, right. So multiple processor scheduling, multiple CPU are available, and hence load sharing becomes possible, right. So multiple processor scheduling, multiple CPU are available, right. So with the help of if you want to work on the multiple processor, then what we have required multiple CPUs as well as for load sharing becomes possible. However, multiple processor scheduling is more complex. What we have seen over here, that if we are going to discuss about the multi-processor, then multiple process scheduling is more complex as compared to the single processor scheduling. If we are going to discuss single processing, means it means that there is a single processing executions with the CPU. But in the multiple processor, it means that there is a certain kind of complex things is over there. So in multiple processor scheduling, there are cases where the processors are identical, okay, homogeneous in terms of their functionalities. If we are going to discuss multiple processor scheduling, then we can divide it into the homogeneous data. Like if suppose any kind of data which is relevant with programming, any kind of data which is relevant with any kind of files which is very relevant with each other. So we can use any processor available to run any process in a queue, right. So with the help of multiple processing, we can say that we can implement any kind of processor in the queue, right. So basically, if we define that what is the multiprocessor actually, so multiprocessor is a system where with several processes. It means that multiple processes are executed at a same time, right. So there is nothing, there is not a big logic is over there. Only thing is understand for the understand is all about that you want to execute your multiple process at simultaneously, right. So this is all about the concept of the multiprocessor. So, well, with presence of multiple processor, it becomes complex to design a scheduling algorithms, right? So, if suppose we are supposed to be going with presence of multiple processor, so it becomes complex, right? So, multiple process system can be categorized. We can categorize it into the certain kind of parts, like if suppose loosely coupled, okay, so or distributed multiprocess. So, loosely coupled means that multiple processor in system are independent of each other. It means that if multiple processes are running in a system, but they are independent, they are not dependent on each other. Okay, it means there is a loosely coupled, right. So each process in the system has its own memory and IO channels, right. So each and every process have their own memory management, as well as a certain kind of input output channels over there, right? So functionality specialized process. If suppose we are going to discuss about the categorize into the function on the basis of their certain functions, then in a system, among the collection of multiple processors, there is a master process which is general purpose process, right? So here, on the basis of functionality, we can distribute it with the master process, right? So master process control other specialized processor in the system and provides the service to them, right? So tightly coupled, if suppose we are going to discuss about the tightly coupled multiprocessor. So in this system, the process are under integrated control, right, of operating system. All the process in the system share their common memory. So with as compared to the loosely coupled, there is independent, but in tightly coupled multiprocessor, we say that it can what is it, it can share their common memory as well as, right? So these processors are sometimes also termed as a homogeneous, as well as they are identical in terms of their functionalities. In terms of what? In terms of their functionalities. So these are the certain approaches where we are going to discuss about the multiple processor scheduling in fundamental of operating system. Then we must know about the approaches, what kind of approaches is over there. So in this regard, we have already discussed what is the process multiprocessor basically, right? So multiprocessor means that at the same time, we have a multiple in our system, we have a multiple process are executed at the same time, right? So there is if we are going to discuss about the categories, so we can distribute it in the three categories. One is the loosely coupled, second one is the functionality basis, and third one is the tightly coupled, right? So we have gave the certain description about the all the things. Yeah, all right. So now after that, there is a tightly coupled, and now after that there is a approaches to multiple processor scheduling, right? So one approach is like uh, you know just a minute. Okay, fine. So approaches to multiple process scheduling. One approach is when all the scheduling. Now we are going to discuss about the approaches to multiple processor scheduling, right? So one approach is when all the scheduling decisions and I/O processing are handled by a single processor, which is called master server, and other processor executes only the user code, right? So here, if we are going to discuss about the approaches to multiple process, just a minute. Okay, if we are going to discuss about the approaches of approaches to multiple process scheduling, so one approach is when all the scheduling decisions and IO processing are handled by the single processor, which is called master server, and the other processor executes only the user code, right? So if we distribute a multi-processor scheduling with an approach form, that how they can access all about their things, that execution of any kind of process or any kind of job, right? So on the basis of this, we say that we can use master server first of all, okay, and other process executes only the user code, okay. So master server as well as user code is over there, okay. User code means that if user wants to implement or execute any kind of job over there, so this is simple and reduce the need of data sharing, right? So this is simple, and it can reduce the need of data sharing as well as, right? So this entire scenario is called asymmetric multiprocessing, right? uh, while we are going to discuss about the master server and user code, then we talk about the asymmetric multiprocessing, right? And the second approach is systematic symmetric multiprocessing, where each process is itself scheduling, right? So uh, every process have their own scheduling, and it can each process itself scheduling over there. And then we talk about the we say that it is all about the symmetric processing, multiprocessing. And if there is a master server and the other rest of the code is executed with the help of executes only the user code, so this approach is all about the asymmetric multiprocessing. Okay, we will discuss it in the later in the detailed description. All processes may be in the common ready queue, or each process may have its own private queue for ready processes, right? So the scheduling process further by having schedulers of each process examine the ready queue and select the process of execution, right? So these are the certain keynotes of multiple processing scheduling. If we are going to discuss about the keynotes, then multiprocessing system, we can considering having identical and homogeneous processor in the terms of functionalities, right? So what kind of things are over there? Just a minute. What is the your voice? I'm audible. Students, there is any problem? Samad, I'm audible.
Yes, sir.
Okay, okay, fine. Rashid, please look after yourself. Okay, fine. Now, there is a processor affinity. One thing in the keynote, if we are going to discuss the keynote or multiple processes, scheduling, then process affinity is over there. Symmetric multi-threading concept is there. Load balancing is there, and a technique of multiprocessor scheduling. So these are the keynotes which if we are going to discuss about the multiple processor scheduling, then we can discuss all the things in a queue, right? So technique, if we are going to discuss about the certain kind of techniques of multiprocessor scheduling, then process scheduling can be done in two ways: symmetric multiprocessor scheduling and asymmetric multiprocessing processor scheduling, right? So, which we have already discussed that in asymmetric multiprocessing, one process is assigned as a master process, which handle all the decisions related to the scheduling, right? And along with IO processing and other system activities, right? So, in asymmetric multiprocessing, what thing is happened? One is the master, and it can handle all the activities, right? In the master process, which runs operating system code and use and other slaves process only execute their user code, right? So master can handle all the activities of any process and remaining the child process executes the user code, right? So this is the technique which is used in the asymmetric. But in the symmetric multiprocessing scheduling, while we are going to discuss about the symmetric multiprocessing scheduling, then all the processor in systems are self scheduling, right? Self scheduling means that each process in system either has its own list of processes to be executed, or there may be a common list of process from where the process will executed extract the process to the executed, right? So very much clear about the symmetric and asymmetric multiple process scheduling and all, right? So another term which is very common used in the multi-process scheduling, if we are discuss about the multiprocessor scheduling, then processor affinity. Okay, so processor affinity is also very important, because if we are going to discuss about the multi processor scheduling, then process affinity is very important, because each and every process wants to communicate with each other at the simultaneously, right? So if a device is working, a device have running multiple processes, so they can in the multiple sharing, multiple interference is over there. Okay, so it means that there is a common sharing of memories as well as, right? So processor affinity means the process has a affinity for processor on which it currently running, right? It can what it can process on which it is currently running. When the process run on a specific processor, there are certain effects on the cache memory, right? So if suppose at the same time you are currently all the process are working over there, then what memory is involved, which kind of memory is involved over there? There is a cache memory, right? So the data most recently accessed by the process populated the cache for processor, and the result successive memory accessed by the process is often satisfied in the cache memory, right? So the most of the data, in the process which is communicated in where, in the cache memory, right? So result successive memory access, it's all about the satisfied on the cache memory, because cache memory is the memory where processor can communicate directly. Okay, and it can, it's supposed to be, we have an office, right? For example, and we have a multiple files over there, and we want to work on the same office, and we have it's supposed to be, you are not working in whole office, we have a table, and certain kinds, we have a certain boxes over there, and if supposed to be in officially work, you have required those things that the most commonly use again and again, like stapler. If you are using stapler again and again, then you can put it in the nearby, right? So you can easily access, it's supposed to be, you can use it again and again, like pen, like stapler, like punch machine and all. So what thing happened, that if suppose you are currently processor are executed, then it will be over there, right? It will be where it is on the near, in the cache memory, right? So the the data most recently accessed by the process populated the cache for the processor, and as a result, successive memory accessed by the process is often satisfied in the cache memory. Right now, if the process migrates to another processor, the contents of the cache memory must be invalidated for the first processor, and the cache for the second processor must be re populated, right? So because of the high cost of invalidating and repopulating cache, most of the SMP, means symmetric multiprocessing system try to avoid migration of processes from one process to another, and try to keep a process running on the same processor. So this is all about the processes affinity. So if suppose there is a certain problem between the migration from one process to another process. So this is all about the representation of process affinity. If we are going to discuss about the certain types of process affinity, then we have distributed it into the two parts. One is the soft affinity, and other one is the hard affinity. Okay, so hope you understand that what is the affinity. Affinity basically represents the relation between the processes, how they can communicate, how they can share their values, how they can share their memories, how they can share their execution of their code, right? So this is all about the affinity. And in the soft affinity, when the operating system has a policy of attempting to keep a process running on the same process, but not guaranteeing it will do so, this situation is called soft affinity. All right, so while we are going to attempting the process running in the same process, right? But not guaranteed it will be do so, right? It is not sure that all the processes are running at the same time, right? So that is a representation of soft affinity. But in the hard affinity allows a process to specify subset of processes on which it may run, not sure over there. Some systems such as Linux implements the soft affinity, but also provides some system calls, right? So we have already discussed about the system calls. So a certain schedule set affinity, is also certain kind of system calls which can support the hard affinity as well as, right? So this is all about the affinity, and after the affinity we have another term, that is the load balancing. Okay, so all the things which we have already discussed in this diagram, that this is what is this is all about the keynotes of the multiple process scheduling, right? So from all those, we have a load balancing. So if suppose we are going to discuss about the load balancing in multiple process scheduling, Then load balancing is a phenomena which keeps the workload evenly distributed across all the processor in the SMP. Okay, so basically, what is the SMP? SMP is nothing but it's all about what? It's all about the symmetric multiprocessing. Okay, symmetric multiprocessing, and in symmetric, processing, which we have already discussed, that there is a master, server is over there, right? This is very common thing, that if suppose we are using the symmetric multiprocessing, then we have used a master server over there, right? So load balancing is a necessary only on system where each process has its own private queue of process which are eligible to execute, right? So load balancing is necessary only on system where each process has its own private queue of process which are eligible to execute. Load balancing is unnecessary because once the process becomes idle, it immediately extracts a runnable process from the common run queue. On SMP, symmetric multiprocessing, it is important to keep the workload balancing among all the process and all, right? So there are two general approaches. If suppose you are working with the load balancing, then there is a two multiple approaches over there. One is the push migration and other one is the pull migration. Okay, so this is the technical words, technical terms which is used in the multiple process scheduling, right? So internal functionality, we just aware about that, how they can work, how they can doing all the activities, right? So if we are discuss about the push migration, then in push migration, a task routinely checks the whole load on each process, and if it finds an imbalance, then it evenly distributed load on each process by moving the processes from overloaded to idle or less busy processes, right? So it's all about the push migration, and now after that there is a pull migration. So pull migration occurs when the idle process pulls a waiting task from a busy processor for its execution, right? So it's all about the pull migration. Now we are going to discuss about the detailed description about the symmetric multi-threading. Symmetric multi-threading. So in symmetric multi-threading, symmetric multiple process system has multiple physical process that allows several threads to be executed concurrently, right? So multiple processes are over there, or multiple threads are over there for execution concurrently. Now the idea is to create and provide the logical processor instead of physical processes. Here, discuss the certain kind of ideas over there to provide what it can provide. It can provide the logical processes instead of what? Instead of physical processes. This concept of providing logical processes, to the thread is termed as a symmetric multi-threading and hyper-threading technology for entail processes, right? So the concept of multiple threading, in view that an operating system has several logical processes over there, right? So where every logical process has its own architecture status, right? So this is all about symmetric. Each logical process has its own general purpose and machine state register as well as. With the help of all the state registers, each and every activity has been done. Right, each logical process is capable of handling interrupts and share the resources. Right, physical memory. This is all about that. So you see that in the symmetric multi-threading, right? So logical processor P1, logical processor P2, logical processor here. There is a physical process. There is, but they are simultaneously work over there, right? So this is all about what here you see that you have a four process at the same time. Okay, so this is all about that how they both are working together simultaneously. So it represents what it can represent. It represents the symmetric multi-threading, right? So in this figure above show that view of two physical process have where each of them has created two logical processes. Here from the operating system view, there are four processes to be scheduled, right? Four process has been scheduled over there. The concept basically, if we are going to discuss about the concept of symmetric multi-threading, is more of hardware rather than software, right? So because we aware about that, if we are going to discuss about the multiple process scheduling, then what thing we have required? We have required certain kind of memory management, right? So on the basis of memory management and all, then we fall in the hardware configuration as well as, right? So that is the concept. That's why we said that if we are going to discuss about the symmetric multi-threading, then it is more reliable as compared to the software. It can rely on the hardware as well as, right? It is hardware which is designed in a way that it could provide architecture state to each logical process along with the interrupt handling, right? However, the process system, however, the operating system must not be designed differently to achieve the goal of symmetric multi-threading, right? But if we are going to discuss about the operating system, it designed differently, right? To run on each on such a system, then it can give performance again, right? Consider that symmetric multiprocessing have we have implemented the concept of symmetric multi threading, and we have two physical process and each have only logical process in the figure which is given below, right? So now the both physical process are ideal processor are what this is the ideal. So if operating system is not designed on the concept of symmetric multi-threading and all, then might be happen it should be separate threads on two separate logical processes of the same physical process having another physical process idle, right? So instead of it should be scheduled into the separate threads uh, on two different physical processes, so that at last we should conclude that we can gain performance by scheduling multi-processing system. Still there is a no best solution for the multi-processing scheduling, right? So it's supposed to be we are going to discuss about the multi processing scheduling, then we find out that there is a certain complex things is over there, and with the help of complexity and all, we can distribute it in the different manners and all. So this is all about about the multiple processing scheduling. So in this regard, we have a certain kind of mcqs is over there on the basis of this. So we can first of all we can let us check the certain kind of mcqs about the same. So right, so I just close this now it is visible, Preetham? MCQs is visible, right?
Yes, sir.
Okay. So in a single process system, they only have processor. In single processor system, they only have dash processor. How many? Zero, one, two, or multiple in single processor? Yes, yes. What is the
Sir,
right
D.
answer? A, B, C, D.
One.
D, sir, D.
One. Okay, B is the right answer. B is the right answer. Most computer systems are single processor system, i.e. the only one processor. How many types of multiprocessor? How many types we have discussed? A. A is the right
Sir,
answer.
yes, sir.
Right?
A.
Okay. There are mainly two types of the multiprocessor. One is the symmetric and other one is the asymmetric multiprocessing. Right? So, which multiprocessor system contain a master-slave relationship? Yes, symmetric or single stone or asymmetric.
Sir, C.
Okay, C is the right answer. Asymmetric multiprocessor system has contains master slave relation. Very good. Okay, which of the following disadvantage of multiprocessor system? Multiple process system is quite expensive. Yes. Okay. All the processor in the multiprocessor system share their memory, so much larger pool of memory is required as a compared to the single processor system. Okay, more complex and complicated operating system is required multiple process system, right? So what which
D,
one is
sir.
the reliable? All of
Yes.
the above. Okay, D is the right
D,
answer.
D.
All the above are disadvantage. Okay, now the feature of multi microprocessor architecture. Multi microprocessor architecture. Task dependent single bus provider. So D is the right answer. All the above design for a specific task. So main features of multi microprocessor is that the task dependent. If it is designed for a specific task, then it may not be useful for the other task, right? So main objective of in objectives in building a multi microprocessor is greater throughput, enhance fault tolerance, both A and B, and none of the above. C is the right answer, greater throughput, because greater throughput and enhanced fault tolerance are the main objective of the multi processing, right? So this is all about the MCQs of our uh, uh, you know topic. So I just close.